everyone, I'm Kristel and Celemin from the Batangas State University, Alangilan Campus, taking Bachelor of Science in Information Technology from the section 2105. So, this video is all about the compilations of the activities in chapter 4. So, let's start with the first activity. So, this is the first activity entitled Physical Layer Terminology. So, the instructions is descriptions of the physical layer are provided in the table. So, drag each physical layer term to its description. So, we'll put our answers here, and these are the descriptions. So, the first description is media that uses patterns of microwaves to represent bits. So that is wireless. So we will put the wireless here. So the next is the capacity of a medium to carry data. So that is bandwidth. So the next one is media that uses patterns of light to represent bits. So that is fiber optic. And the next one is a measure of a transfer of bits across the media. So that is the throughput. So the next one is media that uses electrical pulses to represent bits. So that is the copper. So let's check if our answers are all correct. So as we can see here, our answers are all correct. So, let's proceed to the next activity. So, this is the second activity entitled Copper Media Characteristics. So, the instructions is UTP or the unshielded twisted pair, STP or the shielded twisted pair, and the crucial copper media characteristics are provided in the table. So click the appropriate field to match the characteristics of the media type. So the first one is attaches antennas to wireless devices, can be bundled with fiber optic cabling for two-way data transmission. So that is the crucial. So the next one is counters EMI and RFI by using shielding techniques and special connectors. So by the word shielding, so we can conclude that is the STP or the shielded twisted pair. So the next one is the most common network media. So that is the untwisted twisted pair, or the unshielded twisted pair, so or the UTP. So the next one is terminates with BNC, N-type and F-type connector. So that is the crucial also. So let's check if our answers are all correct. So that's it. Our answers are all correct. So let's now proceed to the next activity. So, this is the next activity entitled T568A Cable Pinouts. So, instructions. Correctly align the wire colors to build a TIA or EIA 568A cable pinout. So, drag each wire color to its correct placement on the RJ45 image in the graphic. So we will drag this wire color here. So the first one is the green stripe, then the pure, then or the plain green, then the orange stripe, then The next one is the blue, plain blue, and then the striped blue, then the orange, and then the striped brown, and then the brown. So let's check if it is correct. So that's it. It's all correct. So we can see it's just it has a pattern. So it's alternate of the striped color and the plain color. So let's proceed to the next one. So this one is the bottom view of an RJ45 connector. This one is we'll put the orange stripe, and then the orange, plain orange, then the green stripe, then the blue, then the blue stripe, then the next one is this plain green, and then this stripe brown, and then the plain brown. So let's check again. So that's it. It's all correct. So we can now proceed to the next activity. So this is the next activity entitled Fiber Optics Terminology. So instruction is descriptions of fiber optic media are provided in the table. So click the appropriate field to match the description to the fiber optic cable type. So the first question is, can help data travel approximately 1.24 miles or 2 km per 2000 minutes. So that is multi-mode. So by the way, our choices are multi-mode and single mode. So let's proceed to the second question. So uses light emitting diodes or the LED as a data light source transmitter. So that is also a multi-mode. So the next one is uses lasers in a single stream as a data light source transmitter. So that is a single mode. So the next one is used to connect long distance telephony and cable TV applications. So it is also a single mode. So the next one is can travel approximately 62.5 miles or 100 kilometers per 100,000 minutes. So that is single mode. So the last one is used within a campus network. So that is a multi-mode. So let's check again if our answers are correct. So that's it. Our answers are correct. So we can now proceed to the next activity. So this is the last activity for the chapter 4. So this activity is entitled generic frame fields. So instructions: drag the generic frame field to its correct location on the diagram. So data, type, header, trailer, control, packet, addressing, frame start, error detection, frame start. So we'll put our header here. Where's the header? Header here. and then the packet, and then the trailer. So under the header, we will put here the frame start. So the next one is the addressing, then the type, and then the control. Under the packet, so we will put the data. Then under the trailer, we have the error detection and the frame start. So let's check. So that's it. It's all correct. So we can now go in the next activity. This is the part 2 of the activity. So the instruction is drag and drop the generic frame field to its description. So the first description is contains the IP header, transport layer, PDU, and the data. So it is a data. So the next one is identifies the layer 3 protocol used by the LLC. So it is a type. So the next one is marks the end of the frame. So the frame stop indicator flag. So the next one is identify source and destination host by MAC address. So it is an addressee. Then the last one is specifies special flow services. So that is control. So let's check again. So that's it. Our answers are all correct. So that's it for this video. So thank you so much for watching. Again, this video is all about the activities in the chapter 4. So thank you for watching.